All right, one quick final example then to finish this particular lesson off. What's the object's position at 2 seconds? So it's just running through and it's giving you a feel for what I need you to be able to do. You need to be able to interpret a graph. So going up from 2 seconds, we get to the point, bounce across, and we find that the answer to A is 30 meters. And now we got to be careful here because the question asks about position. Position's like a vector. So we have to state its direction, and they moved 30 meters forward. So remember, this is kind of like your reference point. This is like home. Okay, how far did I move from home? Well, I've moved 30 meters. If I went negative, I moved backwards, so I'm going the opposite way. So I would have moved, instead of going, if I'm looking at Stratford, instead of going to Stratford, I headed towards Seaforth, which I hear is lovely this time of year. So when is the object 90 meters from its starting point? So now it's the reverse. We're actually looking at the y-axis to begin. Here's 90 meters. Move our way across the graph. That's the point. Go down to get time. So therefore, 90 meters forward occurs at 6 seconds. And finally, what's the object's velocity? All right, velocity. So a little bit of a side note here. I need you to make this switch here. I need you to say, hey, velocity is equal to slope. Anyone who's going to take the grade, well, 12 physics for sure, but if you're going to take the grade 12 advanced functions math, if you plan on going on to calculus and vectors, this is a switch you're going to make eventually. So it's great if you can switch your mindset right now. So I'm going to put it in red because it's important. It's never going to go away for us. But velocity, V, is equal to M, and in brackets I'll put slope, which means it's equal to delta y over delta x, which means because it's a velocity, it's equal to our change in displacement over delta t. So this relationship or formula is true all the way through. All right, so that whole thing is always true. So regardless of the information given, and doesn't matter what form, you need to know or recognize that all of those are true. Velocity is just slope of position time graph. So returning to the question then, what is the object's velocity? Because the slope is uniform, okay, because it's a linear relationship, we just have to find the slope. So I'll just put delta y over delta x. Because we're given a graph, there's no sense in inventing the wheel here or making you feel totally uncomfortable, so just find the slope of the line. We can do that anywhere because it's a line. I'm going to pick that first region right here. So that delta y was 30 meters here. Time was 2 seconds. So therefore, I have 30 meters over 2 seconds. So we end up with 15 meters per second as our answer. Okay. So there we go. The first section of homework here is just getting you comfortable working with position time graphs, okay? Interpreting information, getting the forward and backward or the east-west kind of figured out as well, and getting you into that mode before we move on and do some more challenging stuff with it. If you have any questions or anything you need clarified, let me know in class and we'll get that sorted out so you can move on.